Okay, next, let's consider the Doppler effect when the observer is moving towards the source or moving away from the source. Let's see that first. Let the observer be moving towards the source. Okay, let here A is with the source. This is the first compression of the source. Then the next compression of the source. Okay, here at t is equal to 0, the observer observes the first compression. Then the observer is moving towards the source with speed v observer. So during the observed time period, it would have moved distance equal to v naught t naught. And during the observed time period, this compression would have moved up to this distance. And the observer and the compression denoted by compression number, say, C prime, would have made the observer at this distance, observer. So here the distance is, this is the actual distance between the two compressions. That means the wavelength. The distance between this C prime, the compression C prime, and the ball line here is speed of the sound into observed time period, and the distance between the C double prime and this ball line is V naught T naught. Okay. So wavelength is equal to V naught T naught plus Vt naught. Okay. But wavelength is equal to speed of the sound into its actual time period, capital T, is equal to V naught T naught plus Vt naught, implies Vt is equal to V naught plus V into T naught, implies V divided by actual frequency f is equal to V naught plus V into observed frequency f naught. Therefore, observed frequency is equal to V naught plus V into f divided by V. Okay, this is the relation between the observed frequency and the actual frequency when the observer is moving towards the source with the speed V naught. Here, note down that capital T is the actual time period of the wave, but T naught is the observed time period of the wave as observed by the observer, which is moving with the speed V naught towards the source. Now, let's consider the next case when the source is stationary and the observer is moving away from the source. Observer is moving away from the source. Observer is moving away from the source. Okay. So let this compression be the C prime or C1 and this compression be the C2. Okay. Let the observer meet C2, the compression, at t is equal to 0. Okay, here is the observer. Okay. Then during the observed time period, capital T naught, it would have moved away from the source with a distance equal to V naught into T naught. This is the distance traveled away from the source. And then the observer, this compression C1 would have moved up to this distance and they would have met. Okay, so we have here the distance, the gap between the two dotted circles is the actual wavelength, lambda, and lambda is equal to speed of the wave into actual time period. Okay. So, but this is the apparent, this is the ball line, and C1, the distance between this compression C1 and the ball circle is the observed wavelength, lambda naught, observed wavelength. This is equal to 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 speed of the sound into its time period. capital T naught. Okay. So here we have the actual wavelength lambda is equal to the apparent wavelength. That means Bt naught apparent wavelength lambda prime minus distance move B naught T naught. Okay. But lambda prime, that means observed wavelength, lambda naught. Okay, I have written that lambda prime is equal to lambda naught. So I'm removing it so that the sign becomes in conformity with the signs as used above. Now lambda naught is equal to Bt naught, okay, minus B naught T naught, implies Bt is equal to, because lambda is the wavelength of the actual wave, so B minus B naught into T naught implies B by F is equal to B minus B naught divided by F naught. Observed frequency implies observed frequency is equal to B minus B naught divided by V into actual frequency. This is the relation between the observed frequency and the actual frequency when the observer is moving away from the source with the speed B naught. Okay. After this we want to discuss, but there are cases when both the source and the observer is moving away from one another and moving towards each other, something like that. Okay, let's consider that afterwards. But today, let's discuss up to this point. Thank you.